Hey everyone, welcome back to the channel. Today we are going to discuss a very practical Kubernetes concept that almost every DevOps engineer faces in a real-time project, which is called NodeSelector. Have you ever wondered how can I tell Kubernetes to run my pod on the specific server or specific machine in my Kubernetes cluster? That's exactly what we will solve today by using NodeSelector. By the end of this video, you will be very clear on what is NodeSelector, why we need it, and then how it actually works internally, when to use this NodeSelector, and finally, we will see few real-time use cases with the live demo. That is how we can split up this session today. So let's get started. Before jumping into the NodeSelector, let's understand the problem statement first. Imagine you have Kubernetes cluster with the three nodes. Node 1 is regular server, node 2 is server with the SSD storage, and then the node 3 is test server. Now, since you run kubectl apply-f pod.yaml, what happens? Kubernetes is a smart and automatic scheduler. The scheduler looks at all the available nodes and checks which one has the free capacity or resources available and create the pod there, right? However, there is a problem is there. So what if you want your database part to run only on the SSD node, or what if you want your test application to run only on the test server? And what if you want your GPU workloads to run only on your GPU nodes? So here automatic scheduling does not understand your project or business requirement. So the big question here is, how do you tell Kubernetes where exactly to create our pod? That is where NodeSelector becomes extremely important. All right. So what exactly is the NodeSelector? NodeSelector is a simple label-based scheduling mechanism in Kubernetes, basically, which we can use to schedule and run your pod to the particular server or mission in your Kubernetes cluster. So for this, first we need to label your node with the key value pair, and then you tell your pod, hey, only run on nodes that have this label. Then Kubernetes scheduler checks all the nodes, find the matching label, and create the pods there. Okay. Now you might be thinking, why do we need this node selector? Anyway, the Kubernetes already handles scheduling automatically, right? Then again, why need this? Of course, let me give you real-time scenario where the node selectors becomes absolutely essential for us. There are multiple scenarios are there. Let me talk to you few things here. So there might be a hardware specification workloads. Your ML model really needs GPU nodes, but only 2 out of 10 nodes have the GPUs. So without node selector, your pod might be land on the non-GPU nodes and then it crashed. And then coming to the next scenario where we can see for environment separation. So you have dedicated test servers and production servers in the same cluster. You want to ensure test pods never runs on the production server, and then you want to ensure production pods never runs on the test server. So these scenarios using node selector, you can label to the test server and production server, and you can update it into the YAML file, and you can schedule the parts accordingly. Then coming to the scenario 3, where we can use for performance optimization, your high traffic application needs SSD storage for speed up the application. You must ensure it runs only on the SSD node. In this scenario also we can use node selector to label it and deploy that applications. And then We'll come to the compliances and security perspective. For banking or healthcare applications, certain workloads must run on the specific compliant servers. So that case, using NodeSelector, label the node and schedule the pod on it. And finally, we will see for that cost optimization as well. So in this all cases, we can use NodeSelector, we can label the node, and we can update that into the pod spec, and we can deploy it accordingly. Now let's understand how NodeSelector actually works step by step. Basically, there are three main steps are there. So the first step is you need to label at least one node. This is like putting a name tag on the server. And in the second step, in your pod specification, you add a NodeSelector field with the matching label. This is where the scheduling magic happen. And finally, we can apply and verify. When you apply the pod, Kubernetes scheduler checks all the nodes in the cluster, looks for the nodes with the matching labels. If it is found, create the pod. If it is not found, pod stays in the pending state. So let me show you the complete flow with the example. Now let's do a live demo. I will show you exactly how this works in real-time Kubernetes. So here are the commands. Let me execute this one by one. Okay. Now check available nodes first. kubectl get nodes. See here, only one node is there, that is control plane. For your information, so I was using Minikube. So only one server has that worker node and it is a control plane. It acts as a both. Okay. So now what we can do, let's label one of these nodes. I will call it as a test server. So let me do the label and I will call it as a test server. kubectl label node, and I am giving the node name and space. I can give my node is equal to test server. So I have done the label. Then kubectl get nodes hyphen show hyphen labels. So see here, our label is available here. So we will do the live demo now. Let's create a pod YAML file that uses the node selector now. Now this is the pod. So let me take this one, am pod.yaml. So this is the code. So let me break down this. Under that meta.labels, this is just a normal pod label. It has nothing to do with the scheduling. This is where you are organizing your pods actually. Then comes to the node selector part. This is where the magic happens. Basically, this tells Kubernetes, hey, find me a node that has the label my node is equal to test server. Only create this pod on that specific node. If no node has this label, keep this pod in the pending state. And then under the spec section, here the container is there. Just runs a simple loop printing. This is a node selector every 10 seconds. The key thing to remember here is node selector is the scheduling rule. Okay, let me save this. And then we will apply and verify. kubectl apply -f pod.yaml. So there might be some syntax issue, pod.yaml, and here if we can see some indentation issue. Then save this. kubectl apply in pod.yaml. kubectl get parts and -w, it is watching. It's running now. Okay. Now what we can do, kubectl describe pod. You can give this pod name. Now see, the node selector has the taken label and the pod is scheduled on this node actually. So this is the node IP for that. kubectl get nodes if we can do, and here you can verify the node IP -o wide. See here, this is the node and the node here, both are same actually. So there are two possible scenarios here. Pod is running means Kubernetes found a node with the matching label and successfully scheduled the pod. Let's see which is not running. So where the scenario 2, if the pod is pending state, how we can debug it. Now I'm going to modify something in the pod.yaml. So here I am not doing any labeling and all. Just I am changing the my node name server 2, and here I am putting node label 2. Okay. Now kubectl apply -f pod.yaml, kubectl get pods. Now see it is in pending state. Okay. So this is a scenario 2 we are checking actually. Now what we can do, how to debug this or how to troubleshoot this. Of course, this is a really common issue. So let me show you how to debug this issue when a pod is in stuck or when it is in pending state. So we need to use the kubectl describe, and you can give pod name you can give. Okay. So look at the event section at the bottom. You will see something like 0/1. That means the pod is not coming up. Okay. So what is the exact reason why it's not coming up? So this clearly tells you, hey, I checked all the nodes, but none of them have this label you specified. Whatever the we specified, right? Test server 2, that test servers, none of that node having this label. So that is the reason pod did not come up. So how to fix this actually? So what we can do, we need to do the label, and then the pod automatically gets scheduled. You no need to recreate it, since the scheduler continuously checks for the matching nodes and it will be scheduled automatically. kubectl label node name. This is my node name, and paste it. Then I am giving my node is equal to test server 2 hyphen overwrite. So this is the command we have seen previously. Now the label is created. Now we can check that kubectl get parts. Now it is see it's running. Okay, perfect. Now this is how we can troubleshoot that. First we should have to verify the events, then we can see it. See, but here you can think NodeSelector is still widely used because it is a very simple and predictable, but even there was some limitations are there. So what NodeSelector cannot do is, so no complex conditions using NodeSelector cannot be do it. So that means SSD or some NVM nodes. If you want to R condition, that should not be do, and even should not be perform that logic. So prefer X and fall back to the Y. That also not possible. Even there might be some advanced rules are there, like CPU or core more than 4 you need to trigger. That case it is not possible. So that is where we use node affinity. We can perform all the advanced rules and the prefer logic. Okay, we'll discuss in the next video. Okay, all right. Let's wrap this up with the quick summary. So what we learned today, what is a node selector? It is a simple label based mechanism to control pod scheduling. Why do you need it? So automatically scheduling does not understand your business requirement. So that is where node selector will use it, and we can do the labeling, and then we can schedule it. How it works? So first we need to do the label the nodes, add the node selector to the pod, and scheduler will matches and it will take care. And then when to use it, hardware needs and environment separation, compliances, performance optimization perspective, we can use it. And then coming to the final conclusion, if you found this video helpful, could you please hit and like button and subscribe for more Kubernetes videos? Could you please share with your DevOps friends actually? So in the next video, we will see node affinity, and we will see the difference between node selector and node affinity. And if you have any questions, could you please drop them in the comments, and I will answer every single one. And check out my Kubernetes playlist for complete DevOps tutorial. Until next time, keep learning, keep growing. See you in the next video. Have a nice day. Thank you very much.